Well, thank you. Good morning, everybody. Hey, I see a lot of familiar faces. I'm not sure I should be standing here in front of you. But good morning, and thank you very much for coming so early. What I would like to do is briefly give you an extremely short history of AI. There will be some inaccuracies because I wasn't there. So I have to depend a lot on other people's recollection. I also have to, read up stuff on Wikipedia and stuff like that. So I have to do the best I can. So please bear with me. I hope this will be useful for you. So let's go back to sometime in 1948. Anybody who was born in 1948 sitting in this audience? Wow, there's nobody. Okay, so I can say anything I want. Let me just play this video. It's about 2 minutes.
In a simple villa outskirts of Bristol lives Dr. Gray Walter, a neurologist, who makes robots as a hobby. They are small and he doesn't dress them up to look like men. He calls them tortoises. And so cunningly have their insides been designed that they respond to the stimuli of light and touch in a completely lifelike manner. Elsie, and she sees out of a photoelectric cell which rotates above her body. When light strikes the cell, driving and steering mechanism sends her hurrying towards it. And if she brushes against any object in her path, contacts are operated that turn the steering away, and so automatically she takes avoiding action. Is Elmer, Elsie's brother, in the darker vest. He works in exactly the same way. Dr. Walter says that his electronic toys work exactly as though they have a simple two-cell nervous system, and that with more cells they will be able to do many more tricks. Already Elsie has one up on Elmer. When her batteries begin to fail, she automatically runs home to her kennel for charging up, and in consequence can live a much gayer life.
All right, how many of you think there was any software running in that robot? Anybody thinking there is software in that robot? Raise your hands. Don't be shy. All right, one person. Well, unfortunately, the one person is wrong. There's actually no software inside. The entire robot is mechanical. It's all on gears and battery, and that's it. But it was still able to detect where it was and go back and avoid hitting something else, which is quite phenomenal for a mechanical robot, 100% mechanical robot. So you don't need software for that. But today, we don't talk about that from that perspective. Sorry, let me just go back. Come on. Okay. Anybody recognize this guy? I'll tell you his name. His last name is Turing. What's his first name? Alan. So Alan Turing. Now, I deliberately made this picture with ones and zeros because I think that fits him very well. And he did propose something called the Turing test to test whether the thing that you are talking to, whether it is human or non-human. But the way he came to that idea was there was a paper he wrote in 1950. Anybody born in 1950 in this audience? Nobody, right? He wrote a book, wrote a paper, and in that paper, he asked the question, can machines think? So he felt that that was the wrong question to ask. And he rephrased it, and he called it the imitation game. How many of you think you have heard that phrase before? The imitation game. There is a movie called The Imitation Game, which is based on this. And it's all based on Alan Turing. So look it up, watch the movie later. But that's really a starting point for everything about AI. So fast forward a few years, in 1956, a bunch of people gathered at Dartmouth College in the US. It was led by this Professor John McCarthy, and he brought in a few other people, Marvin Minsky, Claude Shannon. Some of the names should ring a bell in a telecoms institute. So they came together, and eventually that discussion that went on for about 8 weeks, they coined the phrase artificial intelligence. Whether that's the right thing to have been done, we don't know, but that's what happened. But the problem in the early days was the kind of AI that was being done was really about logic, about playing games like chess. It's not even chess. You know, checkers. It's not chess. It's the simpler. There's in England or at least in Singapore, we call it draft or the black and white checkerboards. So that's the game that this was initially written to play, to show that it can be done. Now, these are some of the guys who attended that first meeting in 1956. Yes, it's all guys. There are no ladies there, which we have to fix, and I think we have been fixing ever since. But nonetheless, they were the ones who set motion the idea of AI. And this is the commemorative plaque that is in Dartmouth College that says that this was the meeting, the room where it was held, and so on and so forth. This was actually put up in 2006 on the 50th anniversary. So what happened after that was the idea of a perceptron. The perceptron was actually an algorithm that was running in a piece of, in an IBM mainframe computer, the IBM 704. And basically what it was trying to do is to simulate how neurons work in software. And the researchers decided that they have to do something more than software. They decided to build a piece of hardware that actually implements the neurons. And that was called the Mark I perceptron. And I'll show you a picture shortly. But before that, this Mark I perceptron was the very, very first known implementation of an artificial neural network. We don't know anything else, but this is the only thing that we are aware of. Now, you may have heard of the term AI winter. AI winter basically suggests that all the work that was done suddenly becomes undoable to continue because either there was lack of funding, no more interest, so the entire interest just goes down. In the curve, you can see it is just falling off. So it was called first AI winter because this was actually a very difficult thing to do. It was not progressing as fast as we would like it to be. So this was the very first Mark I perceptron, which is physically located right now at the Smithsonian Museum. But if you look at the size, it's probably the size of this entire projector. And this is just one neuron. So from the 70s onwards, there was additional research that went on to make sure that the other ideas could be developed. And the idea that most of us are familiar with from traditional AI is this thing called symbolic AI and knowledge representation. These are the two areas your traditional AI is known for. That evolved into expert systems. Expert systems are saying, like, I go to see a doctor and there's a bunch of questions and hopefully there's enough background information that can give you an answer. It's an expert system. And this was also limited because the knowledge engineering and reasoning was not good enough, not advanced enough to make it useful. From my personal perspective, the late 1980s, I was in school in the United States and I was doing AI-related work with my professor, and all the things that we did was expert systems, knowledge engineering, and to me that was very boring. I didn't enjoy the AI that was doing in the late 1980s. But it was interesting from my point of view because there is a possibility that something might happen later on. How many of you recognize this map? Anybody? Just put up your hand. All right, one person. Anybody else? All right, 2, 3. Okay, great. This was the map of the predecessor of the internet that you and I are all using right now. This is the map as of 1973. These were different nodes connected on this thing called ARPANET. Why am I showing this here? It's because you needed connectivity between different systems to do anything more than what happens within your lab, within your lab, your laptop, your desktop, your server. You need to have connectivity because you need to be able to engage with external systems. Now, of course, the internet doesn't look like this anymore. All right, it's much larger than this. So we fast forward into the 1980s and 1990s. A lot of new ways of doing stuff with statistical learning. The idea here is if you can go through dictionaries, language dictionaries to look at all the words, how frequently they appear in text, in books, and so on, and try and figure out what ways you can to analyze and do language translation, for example. So using statistical learning algorithms became an interesting idea that people were pursuing. One of the forms of that was something called a support vector machine. Don't worry about the term. The idea here is this was a form of a neural net. Not entirely accurately describing neural net in that sense, but it is a close representation to that. Again, the idea was to focus on data-driven approaches. What do I mean by data-driven? You need to have data in order to figure out what is it that you're trying to do. On its own, it's very difficult to figure out without corresponding data the type of outputs you're trying to achieve. Now, all of this laid the groundwork for future advances. What kind of groundwork do you think needed to be done? I showed you a map earlier of the ARPANET in 1973. Now, let me show you the next one here. This was the infrastructure, the word I used, the groundwork. This was the groundwork that needed to be done so that we can do what we are doing today with AI and stuff like that. So this is from a website called Inframedia. All the lines you see are undersea cables, which probably most of them today are all fiber cables, so that it connects various countries around the world, and this gives you what is known today as the internet. The internet rides on these wires and these cables and these fiber optic connections between different parts of the planet. Because you can do this today, we now are in a far better position to now tackle the whole idea of AI. So with increased computational power, because our CPUs became better, we had more storage was getting cheaper. So now I can store information that now I can go and analyze later on because I have storage. If I can't store something, I can't do analysis. So it was many things that need to have happened before we can come to today in 2024 and talk about AI. So because of the fact that you had all of this additional stuff happening, it revived the idea of neural networks. When I was in school, we were talking about a 3-layer neural network: an input layer, a middle layer, and an output layer. I remember asking my professor, I said, "Isn't that too shallow?" He said, "Well, that's the best we can do. Because we didn't have hardware, we couldn't do a lot of things. But the brain is not like that. The brain has got multiple layers. How many layers do we need? I don't know." So today we can do that. We can have multiple layers, and that's why we are seeing what we are seeing today. So some of the breakthroughs that have happened because of the multiple layers you can go through is especially image recognition. I think image recognition is one of the earliest manifestations of AI usage that you and I can recognize. When you see in a camera, you see a little square coming up and say, "Oh, that's a face is there." Sometimes, I'm sure over the COVID period, when you had to go online and you have your camera on you, you can move away and put your photograph there. It will still pick up the photograph as if you are sitting there. And you can have your photograph next to you, and you have 2 heads. The system couldn't figure out there's supposed to be only 1 head, but it will still pick up the photograph. So you can still fool the system because the system is designed to pick up only faces, right? So it's interesting what can be done and what has been done, and now we need to move forward from there. We have this whole idea, I don't know how many of you would have heard, especially those of you who are industry in the 2010s, this whole idea of big data. Oh, we got a lot of data that we're going to be collecting, IoT data, information about your switches, your lights, your air conditioning, your traffic, all kinds of data. We want to collect all of these things. What do you want to do with it? We want to do some computation with it. The big data was what started then. And today you have big data sitting in all kinds of places. And the idea of this cloud computing. Remember, cloud computers is nothing more than somebody else's computer. It's not yours, it's somebody else's. And you need to trust that cloud computer to do the right thing for you. All right? But nevertheless, cloud computing came forward because, firstly, you had the infrastructure in place, the data centers were being rolled out, CPU was getting cheaper, RAM was getting cheaper, storage was getting very, very cheap. So now I can store a lot of stuff. And that allowed the idea of making AI accessible to every one of us. So democratization of AI. So we move forward. Other ideas came along. Deep learning. What is deep learning? How do you really understand what is going on in a particular data set? These are applications that are currently being used in self-driving cars. It may work 99% of the time, but that 1% of time it doesn't work, it kills somebody, we have a problem. But yes, let's try, let's learn, let's figure out how to do this even better. The last bullet point is about ethical considerations for AI. As you have all of this data that you accumulate, what do you do with these things? What are the kind of uses are you going to use it for? What use cases will there be? Are you doing it fairly? Are you biased in terms of the analysis? What is it? We need to address these things today, because if we don't do it, it is going to be very difficult to go fix it later. Now, just a nice picture. I wanted to show you some colors. So let's go to the next one. So we have all of this stuff driven based on the usage of open source technology. None of whatever I spoke about could have happened if the code was not available for people to test out, to try, to share, to improve, to break it, to fix it, and make it even better. Open source has driven the way. And so two of the more popular ones for AI usage, PyTorch and TensorFlow. There are a lot more. I just highlighted two, mainly because I like the logos. So logos are kind of pretty, so I decided to put the logos up there. But the thing is, this is what is driving innovation across the industry. The likes of the various cloud service providers who are creating their own AI solutions could not have done any of this if it's not for open source software. It's impossible to do. So we move forward to, again, in this decade, the 2020s. We have, in today's context, the idea of a foundational model. The speaker earlier was talking about foundational models, LLMs, and so on. That's great because now we have the opportunity to take a lot of data, billions and billions of words, images, audio, video, and to do something with it. What is the something? To make it useful for you to make analysis so that you can act on it for some other use case. I wanted to highlight a few things that has happened in the last maybe 3 years, 2 to 3 years. When you have many models, foundational models, whether it's a large language model, a small language model, SLM or LLM, I don't care which one it is, you're not restricted to only using one. You can use many. If I'm going to use many of this at the same time, how would I do that? So there is this concept called mixture of experts. So you have a piece of software that runs in front of a bunch of language models, foundation models, and this front end will decide which of these to send the data to, your queries, your prompts, and so on. Now, this allows you to have a very, very useful and powerful way to do AI-related work from a generative AI perspective. And because, again, to me, open source is the bottom line for everything, there is an open MOE project that has been done, and you're welcome to participate and contribute to how do you do the front end so that you can now talk to language models that are open source at the back end. Now, again, the speaker earlier talked about retrieval augmented generation. I think this is a great idea. This is really what a lot of us require. If I can have a language model that then reads my data in my own environment, I don't want to send it to the cloud. I want to only have it in my environment, maybe my laptop, maybe my server in my organization or in my local area network or at home. I want to now let it search my email, my PDFs, my spreadsheets. I don't care what I have. I want you to read that, and then when I ask this language model something, it should be able to give me an answer. Now that to me makes a lot of sense from a generative AI perspective for you and I to use. So the RAG is a great way to do that. Again, other things that we need to also do today, things like testing of AI solutions. You need to always be testing. You need to make sure that when you deploy a solution that it's not going to be unfair, it's going to be unbiased, it's going to be transparent, and you can explain why does that AI solution do what it does. So I'm representing AI Verify Foundation. We are based in Singapore, and we do have a bunch of software tools called AI Verify Toolkit, which is on GitHub. It's on an Apache license. So please take that, improve it, give us feedback, see what makes sense, and let's make this work for not only for the geeks in this audience, but for everybody else on the planet so that we can all collectively do better. And so what's the future? The future is there will be a term that you will see, sovereign AI. The sovereign AI is about nation states wanting to do their own AI. That means a country wanting to do their own AI. Another one which I am very excited to also be part of is something called Kwai. This is personal AI. That means you have your own stuff for yourself. And the last one is we have a bunch of frameworks that the AI Verify Foundation has put out on governance. So please visit our website to see what that is and be able to collaborate and contribute to it. So these are all the links that I had. And with that, I thank you very much. And you can join us on Matrix. We have our entire chat community and the community for AI Verify on Matrix. So you're welcome to join us. Thank you very much.